week 3, let's get into it. We're going to look at perimeter and area. Now, you might see some funny drawings on your screen there. I need to explain what's going on. So we have 3 diagrams here, and I've got here 1D, 2D, and 3D. All right, don't be scared about that. One dimension, length is a dimension, distance is a dimension. Okay, for example, if we look at the shape in the middle here, this rectangle, it has 2 dimensions. Okay, it has length and it has width or breadth. So those are 2 dimensions. So we say this is a 2D shape. All right, it's got 2 dimensions. So the first diagram, this one over here, it only has 1 dimension. So it is a 1D shape. And then on Thursday, we're going to have a look when we add a 3rd dimension. All right, so we'll have a look at 3D shapes on Thursday. But for today, we don't have to worry about 3D, so we can leave that one off. We are just going to focus on 1D and 2D today. We have done some work with 1 dimension length, but we're going to try and focus in on 2 dimensions today. All right, so 2 dimensions, area, that's what we're going to focus on today. We're going to do some perimeter, but we're going to try and get all these 2D area questions right today. Okay, so those are the dimensions we're going to cover today. Thursday we'll cover the 3D. All right. Now, before we get into the calculations with 2 dimensions, we need to know the formulas. All right, the formulae, if you want to use proper English. And the good news is, for everyone, is that the formula must be given for this measurement section in the exam. All right, the formulas, when you do these calculations with these shapes, they must be given to you, which is fantastic. Now, it doesn't mean that you're off the hook. You need to know what goes where in the formulas, and sometimes they can be tricky, and we're going to have a look at that today. But the formulas will always be given to you. I'm going to run through them so that we are familiar with them. So when they give us the formula, we know what is what, and we know where to put our values in. So I'm going to run through all the formulas. You've got to bear with me before we start calculating. Let's check these formulas out and see what is what's going on here. All right. So we're going to look at perimeter, which is a length or distance, and then we're going to look at area. Now, the definition of perimeter is the outside boundary of a shape. So look at this rectangular shape here. Okay, this rectangle, you got to pretend that it is let's pretend it's a football field. All right, if you were to walk along the boundary of this football field, the boundary of this shape, how far would you walk? What would the length be of that walk? Okay, so it's 1-dimensional. It looks 2-dimensional because you've got length and width, but you're walking along that black line. Okay, you're not covering the area between the lines. You're walking along that line. All right, the whole distance along that line. So you've got to cover a length over there. You've got to cover a width over here. You've got to cover another length, and you've got to cover another width over here. So there's 4 lines you've got to cover, which make 1 boundary in total. And you need to find out what is the length of that line, that boundary. So we call that boundary the perimeter. Okay. So the perimeter of a shape is the boundary of a shape. Well, how long is the boundary of a shape if you had to walk along it? Okay. Now, to work out perimeter, we're going to say it's P for perimeter. This is the formula. All right. Now, you might be thinking, what is this funny little squiggle here? All right. It's my way of writing an L, because if I remove this funny squiggle and I put an L there, okay, some people, especially if you're doing maths, are going to think it's a 1. All right. So to avoid any confusion, my apologies, let's go back down here. To avoid any confusion, I'm going to write my L's in cursive. Okay, so it looks like that. So when you see an L like that, it's L for length. All right, so the formula is I need a length and a width times 2. All right, because I've got 2 lengths, 1 there, 1 there, and I've got 2 widths, 1 there and 1 there. Okay, now Sometimes they don't use a W. Sometimes they will use an L and a B. All right. The B stands for breadth. So they can use width or breadth. It's interchangeable. Often they use width, but sometimes they can use breadth. It's the same thing. So width and breadth are exactly the same thing. Don't worry about that. Okay. But the length is usually the long line, and the width or the breadth is usually the short line. All right. So you need a length and a width times 2. 4 pieces. Okay. Let's look at its friend over here. All right. Another rectangle. And we need to work out its area now. All right. So I'm going to use A for area. So A for area is equal to length times width. Some people remember it as length times breadth. Again, breadth and width, same thing. All right. So length times breadth or length times width, doesn't matter. It's the same thing. Okay. So you need to multiply those dimensions, and that will give you all the space between the boundary lines. Okay. That's 2 dimensions. All right. 2 dimensions, when you multiply them together, will give you all the space between the boundary lines. All right. Perimeter is walking along the boundary line to give you length, but area is all the space between the boundary lines. Please don't forget that. Okay, so that's the rectangle done. Now, squares act in the same way. Okay, I haven't drawn a square on you, but they act in the same way. And sometimes, let me go over here and quickly draw a square for you. All right, we don't want a red square. Let's put a square up here. So sometimes when they give you a square, they'll only give you L. All right, they'll just give you L, and they'll say the area of the square is L squared. All right, to the power of 2. That's okay, because we know that a square, all the sides are the same. So every side is actually L. So this formula can be written as L times L. Instead of length times breadth, it's length times length, because all the sides of a square are the same. So if you're calling one length, you've got to call them all length. And to work out the area, it's length times length. And L times L is L squared. All right, so when you see L squared, don't stress. It's just another way of writing the square formula. It works the same way. You just need to know where to put a value into that L. Okay, so squares work exactly the same way, but they have all their sides the same. All right, how are we doing so far? I hope everyone's with me. All right, well, Gama, unfortunately, we can't start over. I'm going to have to ask you to have a look at the video when it comes out for that section that you missed. We've got to plow ahead because we've got a lot to cover in this lesson. So I have to continue, okay? If you've joined late, I'm going to ask you please to have a look at the video when it comes through. We're going to continue with this, otherwise we're going to get stuck. There's quite a few formulas to get on with. All right, let's move on to the triangle now, okay? I've got the triangle and the circle there. Let me take the circle away because I know what you guys are like. You're going to start staring at the circle formula. All right, so there are the triangles. All right, let me just quickly readjust everything here to make some space. I don't want to cut off any pieces. All right, whoops, cut off a piece there. Let's try again. In fact, we'll just delete this. And then we won't cut anything off. All right, I don't want to chop things. Okay, there's the rectangle. And let's make some space here for the triangle. All right, we'll redraw the R later on. All right, so there's the triangle. And we're going to look at perimeter first. So I've got my P here for perimeter. Perimeter is the length of the boundary of the triangle. Okay, so to work out the boundary of the triangle, I need to work out how long are all the sides. How many sides do I have? I've got 1, 2, 3 sides. So I need their lengths added together. Okay, so I've got S1 plus S2 plus S3. It's the one side plus another side plus a third side. All right. I just called them S1, S2, S3. I didn't call them S and S and S because that would mean all three sides are the same. So we say S1, S2, S3, because they could all be different. Okay, but you need three sides. You add them all up to work out the perimeter of a triangle. All right. Now, the area of a triangle. Now, for those of you that have seen the area formula, you might be looking at this and thinking, what on earth is that and that? What are these funny things? All right, let me explain to you. So the formula for the area of a triangle is you got to take half of the base of the triangle. So we need to find a base for the triangle and multiply that by the perpendicular height. Now, what do I mean by perpendicular? So if you have a line and you put another line on it that's perpendicular, then you have to draw a line up exactly at 90 degrees. Okay. So you have to draw a line exactly at 90 degrees from that line there. All right. So those two lines there meet perpendicularly. They're exactly at 90 degrees. And how we know they are 90 degrees is we draw a little box there like that, which shows that these two lines are perpendicular to each other. Okay, they're meeting at 90 degrees. This angle here is 90 degrees. All right, so those two lines are called perpendicular lines. Now, the symbol for perpendicular comes from this drawing. All right, you see this upside down T? That is the symbol for perpendicular. So when you see that symbol, you'll know that it means perpendicular. All right, so where are these perpendicular lines? All right, so in a normal triangle, I'm going to erase this for now, but we'll put it all back. Okay, whoopsie, there's the triangle. Let's try again. All right, let's just do it like that. So there's a normal triangle. All right, we need the base of the triangle, which is this line here at the bottom where the B is. And then the perpendicular height must come off the base. And that is critical. That is very, very, very important to understand. The perpendicular height that goes in this formula must come off the base, and it must come off the base at 90 degrees. So often they will give you a dotted line coming off the base to show you that that's the perpendicular height. All right. They'll also show you with the symbol that those two lines are perpendicular there. So look for the symbol and look for the dotted line, but that's one way that they often give you a perpendicular height. Okay, so I'm going to highlight the B in my formula for the base. That's this line here at the bottom. And the perpendicular height in my formula is this dotted line that goes up like this. And it must come off the base, and it must be at 90 degrees. Okay? So then to work out the area, you say half the base's length times the perpendicular height's length. So that'll give you the area of a triangle. Okay. All right, let's move on. We've got one more shape that we need to have a look at. Oh, yeah. All right, there's that funny symbol. Okay, we've got circles, which means we've got this funny circle. Can someone please put in chat, what is the symbol over here? What is this symbol here? What is this symbol over here? What is that? What is that? It's pi. Oh, people are spelling it P-I-E, like apple pie, like a steak and kidney pie, pepper steak pie. Okay.
Maybe they're just hungry.
I think they're hungry. Yeah, there we go.
Now we have the correct spelling.
Yeah, there we go. All right, there's a. So it's just PR. Yes, Liz, we are hungry, says Lindsay. Yes, Lindsay, me too. All right, but we're doing something important. Yeah, all right, we've got work to get through. First work, and then the rewards after. All right, I hope, Lindsay, I hope you're having ice cream. You better be having ice cream, because after every mathlet lesson, you need to have ice cream.
Definitely.
All right. So that symbol is pi. Okay. Now, where do we get this thing from? We get it from your calculator, or they give it to you. You don't have to remember it. It's on your calculator. Okay. So if you look at my calculator, down here, above this button that says times 10 to the x is the symbol for par. Okay, so if you don't get given any par, you can create your own par. You just press shift and that button, and there's par. And to see what par is, you can press equals and change it, and that's what the number is. All right, so the calculator has par on it. Par actually has a never-ending supply of decimals, but we only worry about the first three. Okay, so if we look at the first three decimals for this decimal number here, which is par, the third decimal is a 1. Does the 1 change because of the number behind it? Yes. The 5 will change that 1 to a 2. So if we have to use a rounded off, a 3 decimal place rounded off value of par, we will use what I have here on the screen, 3,142. And that's often the value that gets given to you in the exam. They usually give you the par value in the exam, 3,142. It's a rounded off estimation of par. That's usually what they ask you to use. So we just have to put that number into our formula. Wherever we see the symbol for par, we just substitute that value right in there. Okay, so we don't have to worry about that. All right, so let's have a look at our first circle. Now, we don't talk about perimeter when we talk about circles. We talk about circumference. Okay, so this word over here, let's go up a little bit. This word over here, this letter is circumference.
Dale?
Yes.
We have user on chat saying, "Sir, may I please see how you put pi on your calculator?" And can I just say, the person that just texted now, please send me a direct message of your name so that we can address you properly when you have questions.
Okay. All right, sure, I'll show you again. So on the calculator, at the bottom row of buttons, okay, on mine, there's a button that says times 10 to the power of x, right at the bottom. Okay, in the middle, just above that button, you'll see an orange par, which means you have to press shift and then press that button. Okay, and then you'll see par on your calculator screen. To get the value for par, you press equals, and then you press SD to change its value. Okay, and then you'll see its value there. So we're using that decimal, but rounded off to 3 decimal places. So if the question doesn't give you par, and it should tell you what you do. If it doesn't, you can use the calculator par. Okay, but 3 decimal places is pretty safe when you're doing our calculations in math literacy. So back to the formula, we need to work out the perimeter of the circle, right? But we don't call it perimeter for a circle. We call it circumference. So circle doesn't have perimeter, it has circumference. It means the same thing, walking on the boundary of the circle. Okay, if this was a pool, you walk around the pool on the boundary. How far did you walk? All right. Now, to work out circumference, we have 2 formulas. Okay. Formula number 1 is 2 times par times r. Now, what is r? R is this little line here, which is radius, which goes from the center of the circle to the edge of the circle. So from the center to the edge is radius. Yoi. Okay, so R stands for radius. It goes from the center of the circle to the edge, and that's how you can work out circumference. You say 2 times par that they give you, 3,142, times the R that they give you in the question, and you can work out circumference. Now, there is another formula, okay, which is par times D. All right, par times D. Sometimes the D is written with a capital. All right, now D stands for diameter. All right, diameter of a circle is the line going through the center from one side all the way to the other side. So if you go all the way from one side through the center to the other side, that will give you diameter. So if they give you that in the question, you can use formula number 2. All right, now which one should you use? Well, that depends on what they give you. That depends on the question. If you know both, you have options. If they give you radius in the question, use the top one, use number 1. If they give you diameter in the question, use the bottom one, use formula number 2. So it all depends on what they give you, but you have options. Okay, so there are 2 options for circumference.
Dale?
Yes.
We have a question in the chat. Sakila is asking, sir, if I'm calculating for the circumference, would my SI unit be pi?
Okay, good question. I like that question. The man's thinking. All right. So the units that you're going to use in your answer are going to be based on the units that they give you in the question. And we're going to deal with some questions very soon. If they give you a diameter, so let's say they give you a diameter D is equal to 14 centimeters, then that's a length, all right? The length of the circumference, its units must also be in centimeters. All right, so if they give you centimeters, keep your answer in centimeters. But if they give you, listen carefully, we're going to see this now. If they give you centimeters and they ask you for meters, well, then you got to go back to the lessons we had last week and convert centimeters into meters. All right, so check what the question gives you and check what the question wants. You use those same units. Use what they give you or use what they ask of you. Okay. Pi has got no units. It's unitless. It's got nothing to do with the units in the answer. It's based on the dimensions, diameter or radius that they give you in the question. All right. I hope that answers your question, Sakile. Let's go on to the area of a circle. Now, the area of a circle, again, it's a bit small. I don't know if anyone can see that. Let me make it bigger. Area is equal to pi times r squared. Okay. So what we need to do now is find an r, a radius, square it, and multiply it by pi that they give you. Okay. So all we have to do is find a radius from the question, square it, multiply it by pi that they give you. Okay. All right. Those are all our formulas for perimeter area or circumference area. We are now going to take this information. Just please remember, if you think, oh my gosh, how am I going to remember all of this? Don't worry. They give you these formulas. You just have to know how to use them, which is why I've done this explanation. So we need to understand what all these letters are and things like that, what pi is and stuff like that. All right, so I've done a little explanation. Now we can actually go into the questions and they give you the formula. So I'm going to keep these here and we're going to come back to these. We're going to use them in the questions. All right. Now, we are going to try some contextual questions. Up until now, we've been doing some very basic questions. All right, now I don't want you to freak out. You are likely to see most of your tests presented in contextual questions. All right, which means they'll have a question 1 based on a story or a topic, okay? And then there's a whole list of questions based on the topic presented in question 1. All right, there's context. There could be a person that's building a house. There could be someone that's digging a garden. There could be someone that is measuring up his kitchen to lay some tiles. Right, there's a story. They create a story, which is the context, okay, the background to the story. And then they ask you a whole lot of questions based on that one story. All right, so I'm going to give you a contextual question, and then we want to have a look at what questions come after this. Okay, so here is the contextual question. I don't know if you can read it there. I'll read it for you if you can't see. But it says, Mr. Morai, the gardener at school, he is going to create a circular flower bed in a rectangular lawn. And you can see a diagram there that'll help you. It's shown in the diagram. The radius of the flower bed is 1.5 meters. Now, when you read these contextual questions, we're learning skills here. When they give you information like this, radius is 1.5 meters. That's important information. And here it is on the diagram. So I'm just checking. It's in the question. Is it on the diagram? Yes, we got it. Okay. Then they say the length of the rectangular lawn is 6. All right. So length is 6. And I've got that in my question. And then they say the breadth. You see, they're using breadth here instead of width. Remember, I said they're interchangeable. Some people use breadth, some people use width. And the width is 4. So everything in the text is on my diagram. It's important to check, but maybe they write something in the text and they leave it off the diagram. You're not going to read the text again. You're just going to look at the diagram. So everything in my text is on my diagram. Now they want us to calculate here. I don't know if you can see this. Calculate the following, correct to 2 decimal units. Now that's standard. We always use answers and correct them to 2 decimal units. But what if it didn't say correct to 2? They would say correct to 1 decimal. You've got to do exactly what this question asks. Okay. The normal tests, the normal exams will always take in the cover page, round off to 2 decimal places unless they ask you otherwise. So we check in this question, they still want 2. We're going to use 2. We'll do exactly what the question wants. All right. So calculate, what must I calculate? The area of the flower bed. We need the area of the flower bed. And they give us the formula. Area equals pi r squared. That looks like a circle formula. Of course, the flower bed is a circle. And they say pi is not 3,142. They say use pi as 3,14. Fine. You asked me to do that? I'll do that. All right. And r is a radius. Just so that you know that r is a radius. Yeah, Johnny, you don't have to know anything about pi. Okay. It's just a number. It just sits there and we got to use it for circles. Unfortunately, circles have got this magical relationship with this number. Don't ask me why, how they got together. Okay. It's been a long relationship. They just like each other. Circles and pi, they go together. Okay. And I don't know why pi's are also in circles. Don't ask me, but it's circles and pi. They go together. You just got to accept it. Nothing we can do about it. Those 2 things always go together. All right. But they'll always give you that value. You don't have to know it. They'll give it to you. All right. And we just got to put it into our formula. All right. So they want us to calculate area and they give us the formula to use. So for 2.1, here's my formula. You don't have to write it out, but I want to, so I can show you. All right. Pi r squared. So this formula needs pi. They've given us pi. There's pi. I'm going to put it in 3,14. And we're multiplying by r. R is radius. Where's the radius now? That's from the question. It's 1,5 meters. Okay. It's 1,5 meters. Now, be very, very, very careful here. A lot of people will put an M. And then they know that R has to be squared. And they do this. They put the 2 there. Here, I don't know if you've seen that before, but it's such a sad mistake when the guys do that. They put the 2 on the M. And you know what that looks like? It looks like square meters. All right. And they forget to square the 1,5. Okay. So what I usually tell the guys is you can leave the M there if you want. But whenever you see an R and you want to square it, think of it like this. Okay. The whole thing is going to be squared. It's 1,5 squared. All right. Think of it like that. Otherwise, if you don't want to do that, leave the M off. Just leave the M off. You've got to remember it's meters. Leave the M off. And then you must know it's 1,5 squared. That number must be squared, not the M. All right. You are going to change the number. You're going to say 1,5 on your calculator squared. Okay. But guys get confused when they write the M there, and then they put the 2 on the M. Now it looks like square meters. Okay. And they forget to square the 1,5. So the 1,5, guys and girls, needs to be squared. Okay. So if I put meters there, I'm saying this thing, the whole thing must be squared. 1,5 must be squared. All right. Now here's the calculator's work. It's the calculator's job to do this stuff. All right. So 3,14 times. Now look at my calculator. 1,5 squared. There's no M there. There's no M there. It's just the number being squared. Okay. So remember to square the number. All right. And we press equals. Now, if they give you a power with 2 decimals, we shouldn't have too many decimals here. Yeah, that's not too bad. If they use the calculator power, it always gives you lots of decimals, but this is fine. All right. So I'm going to put you equals 7,065. 7,065. Now the units. I think it was Sakili asked me about the units. Area is always square units. So if the radius was given in meters, the final answer must be meters squared. Area is always square units. Okay. Now I want to ask the guys in chat, are you happy with this answer? Has anyone got a problem with my answer? Are you all happy with it? You're going to accept it? Can someone please raise their hand and tell me if I'm okay here with my answer, if you accept it or you don't accept it? Whoa.
Lindsay says she's happy.
Lindsay's happy. Someone raise their hand and tell me why you're not happy with this answer.
Sonia
raise your hand
does
button,
not accept it.
Who says no? Sonia. Sonia, please. Let's unmute Sonia here. Sonia, please talk to us. Can you tell us, Sonia, what's wrong with my answer?
Sonia says rounded off to 2 decimal places. Sakila's asking, shouldn't you round it off to 2 decimal places?
All right. The question wanted 2 decimals. We're going to give them 2 decimals. So we're looking at the 6, the second decimal. Okay, that's the second decimal. Will it change the 5 that's next to it? Yes. If it's 5 and above, it will change the 6. That's going to become 7,07 meters squared. All right, you guys are on the ball. Okay, that's question 2.21 in the bag. Let's look at 2.2. Calculate the perimeter of the rectangle. Use the formula P is equal to 2L plus B, where L is length and B is breadth. So calculate perimeter, and we're given the formula. There's the formula there. All right, we will use that formula. So let's write the formula out. I'm going to write it out, the whole thing. You guys don't have to rewrite the formula. You will not get marks for this. I always rewrite it out. You don't have to. You can start putting numbers in straight away. All right, the length of the rectangle. Well, let's put my 2 there first. I need the length of the rectangle. Where is it? It's up there. It's 6. I'm going to put 6 in. Okay. The breadth of my rectangle was 4. I'm going to put 4 in. Okay. So I don't even need a calculator for this. 6 plus 4 in the brackets is 10. Times it by 2. That gives me 20. Now, is this meters or meters squared? Can someone tell me in chat, please? Meters or meters squared? Yes, the guys are too quick. Meters.
20 meters.
We all said meters. All right. Yes, it's not area. It's perimeter, which is a length. It's 1 dimension. So it's just meters. Very good. I like that name, Giovante. Giovante, that's a cool name. All right, meters. Well done, guys. Just meters. Okay, so I must put, like Kia always says.
Always put your units.
Always put your units. All right, we're doing well here so far. 2.2.3, calculate the length of the lawn in feet. Now, if you were here in week 1, you would have learned about this. We are changing imperial to metric, okay? And remember, if they're changing imperial to metric, they have to give you the conversion. There it is. They gave us the conversion. We need to know the length of the lawn in feet. If 1 meter is 3,25 feet. Now, how many meters is our length? It's 6. All right. So for 2.2.3, we have 6 meters, and every one of them is 3,23 feet. Let me check. Yep. Sorry, 3,25. Every one of those meters is 3,25 feet. So times by 3,25. I'm going to get my calculator to do the work. I'm feeling lazy. So times 3,25. 19,5. Now, what are my units? They want to know what is the feet. So I'll write FT for feet. Okay. All right. Now, the next questions are a little bit higher order. This is where the grade 11s need to step up here, okay? Because often in contextual questions, yes, even if it's a measurement question in the measurement section of the exam, they will ask you sometimes to do bring some finance. All right, so let's have a look at 2.2.4. 2.2.4 says, Mr. Marai would like to install a fence along the boundary of the lawn. Along the boundary of the lawn. That sounds like what? Area or perimeter? Anybody? Along the boundary of the lawn. Along the boundary of the lawn. Is that area or perimeter? Yes, my people. It's perimeter. Well done. So they're talking about the perimeter here. They want to install a fence along the perimeter. And fencing costs 248 Rand 29 per meter. Calculate the total cost of fencing this boundary. Okay, it's perimeter. Now, if we worked out the perimeter of the lawn is the rectangle. Have we worked out perimeter of the rectangle? Ah, we did. We did in question 2.2.2. It's 20 meters. We got that answer. We don't have to recalculate it. Now, every single meter costs 248,29. So a simple calculation would be, let me make some space. Take every meter. How many of them do I have? I've got 20 of them. Each one of those costs, let me go to my question, 248 Rand 29. I bet you the answers are probably flying out already.
Sonke would like to see, would rather let you go back to the formula after 2.2.5.
Oh, you know why? Because Sonke wants to do 225. Oh, after 225.
And then we had,
yeah. And then we've got the answers coming in. It's 3.25 feet given the question. Yes, all right. The answers, I told you the answers are really, yes, we're always right. The question wants us to round off to 2 decimal places. If there's a 0 behind the 8, you can show the 0 as well. All right, yes, these guys are too fast for me.
Yeah, no, hey?
Sometimes these guys are on fire. All right, so times 248,29. Let's see what we get. 4965,8. Exactly like they said. 4965,8. Now, if they say 2, I don't think they'll penalize you if you don't show the 0, but I like to show the second decimal anyway, especially with rands. Okay, rands will always show 2 decimals. Okay, so just show the 0 there. It won't harm you to show the 0. All right, good stuff. Last question, 2.2.5. Calculate the area of the lawn only. Exclude the flower bed. Give your answers in meters squared. Calculate the area of the lawn. Now, the area of the lawn is the rectangle. So what are they actually asking for here? They want the rectangle area, but we've got to exclude, take away, remove, don't include, cut it out, the circle, the flower bed in the middle. So they want all this shaded region that I'm shading in now with red. They want all this, not the circle in the middle. So how we can do that? Oh, please, someone put your microphone on and tell me. Who raise your hand, somebody, and tell me how we're going to do this. I know someone knows up there. Be brave. Raise your hand. Let's unmute your microphone. Talk to us. Anybody?
Somebody. Anybody.
Somebody talk to us.
Lindsay says 6 multiplied by 4.
Well done, Sonke. You did well. 6 times 4. Yes, we've got to do the rectangle area. Okay, so let's do the rectangle area first. So what I like to do is I say A and then I draw the rectangle. All right, this is what I'm going to do. I'm going to take the area of the rectangle and I'm going to take away the area of the circle. Okay, that'll give me my answer. That's what I'm going to do. So what I'm going to do here is I'm going to say area of rectangle first, which is length times breadth, which is 6 meters times 4 meters. And that'll give me 6 times 4, 24. And area is always in meters squared. Now the area of the circle, it just so happens, for question 2.2.1, we've done it already. It's 7,07. We've got it already. 7,07 meters squared. So to find the area of the lawn only, you take the rectangle and you minus the circle. So I'm going to write your area of the lawn. You don't have to write lawn. I just want to show you is the area of the rectangle, which is 24 meters squared, minus the area of the circle, which is 7,07 meters squared. And this will give us our final area. I'm going to use the calculator because I'm lazy and it must work for me. 7,07. 16,93. 16,93 meters squared. Okay. All right. I'm sure even the grade 10s were like, oh, sir, come on, that's too easy. We can do that. All right. Well done. Good job. Now, we don't have much time. Okay. I'm not going to go into capacity today. You guys did a little bit of work. Oh, on Thursday, you're going to work hard when we do capacity. All right. But I want you to see a contextual question where we had to use the formula. And I think someone wanted to see the circle formulas again. There's the circumference. And there's the area. All right. So there are 2 circumference formulas and 1 area formula. Okay. Are there any questions? Oh, sorry. Like, hey, man, go back to the last answer. I was checking it. There we go. There's the last answer. (16,93 meters squared).
Sitogozile is saying math is easier than I thought. I'm enjoying it.
Oh, that's fantastic. That's fantastic. Now, you got to practice, hey? So if your teacher gives you questions to practice, you must be excited to practice them. And it's an awesome feeling when you practice and get it right. If you get it wrong, it's fine, but find out why you're getting it wrong, correct it, and then it'll feel good. It'll feel really good. Okay. Awesome. Yes, I knew. We did conversions a couple of weeks ago. All right, I don't know if you were here a couple of weeks ago, but a couple of weeks ago we did conversions. We've been there. We've done that. Go look at the YouTube channel at Watobe. Go look at the lessons we had a couple of weeks ago. We did conversions there as well. All right, this is the last week of this measurement course. Please go back and look at the Watobe YouTube channel. Go and look at those videos. You can play them over and over again. If there's a certain section you're struggling with, go find it in the YouTube video and play it over and over again. It'll help you out. Okay, awesome, Sakulia. Oh, come on. You promised me money. Ava. It's not all about money. You need to do well. Tariffs. Tariffs that now, Paul, this man knows what's coming and he's worried about tariffs. I would also be worried about tariffs. We're going to do patterns and relationships next, and tariffs. You know, we can show you a tariff under patterns and relationships, but it often comes up in the finance section as well. So I'll show you a tariff table in the patterns and finance, patterns and relationships section, but it's also going to come up in the finance section. And yes, Paul, you know that thing is difficult. Don't worry, I'm going to make it easy for you. We're going to make it easy for you. So when you know that section's coming, look on Watobe website. When you see it coming, make sure that you're there to listen. All right. Are there any other questions about today's work? Are we all feeling good? You guys did a good job. I'm very proud of you. Yeah, we're doing conversions and measurements. We're finishing off this measurement course now. Measurement's actually quite a difficult section in the exam. Measurement and finance are the two big bad ones. They're not bad, but they can be quite challenging. They can put some really challenging questions there. So we're trying to tackle measurement first. Then we're going to go into patterns and relationships next week for 2 weeks. And then we're going to do a little bit of finance. And then we're going to do a little bit of maps and plans and scale. And then later in the year, we will come back to finance and maps and plans. We're also going to do probability. So we will cover the topics or extend the topics a little bit more as we go through the year. Well done, Sito. Yeah, yeah, fantastic.